organic compounds. First of all, we will see the occurrence of organic compounds. Occurrence of organic compounds. Now students, we must know what are from where we get the organic compounds, what are the main sources of organic compounds. Usually we can get organic compounds from living things or from the things that were once living. It means we can get organic compounds. There are two sources of organic compounds. The first one is from living things. We can get them either from living things Living things means we can get them either from plants or we can get them from animals. We can get them from plants or we can get them from animals or from the things which were once alive. That means fossil remains. Fossil remains. These are the sources of organic compounds, or these are the sources from where we get the organic compounds. Fossil remain includes coal, petroleum, as well as natural gas. I hope occurrence of organic compounds, it is clear to you students. Now we will see some more general characteristics of organic compounds. Now next important characteristic of organic compound is their covalent nature. Covalent nature of organic compounds. Now students, if we write some formulas, molecular formulas of organic compounds, for example, natural gas having the molecular formula CH4. Similarly, vinegar, as you have learned in 9th class as well, vinegar CH3 COOH. Similarly, ethanol or alcohol C2H5OH. Acetone CH3COCH3. These are some examples of organic compounds. Students, in these compounds you can notice carbon form covalent bond with other atoms, with hydrogen atoms or with other atoms. Similarly, there is a covalent bonding between all the carbon atoms. It means organic compounds generally they are covalent in nature. They form, in organic compounds, carbon atom is covalently bonded with other carbon atoms as well as with hydrogen atoms and atoms other than carbon and hydrogen like oxygen or nitrogen or sulfur, which shows that all the organic compounds are covalent in nature. Since they are covalent in nature, so either they have polar or non-polar covalent bond. Either they have polar covalent bond or non-polar covalent bond. For example, here in methane, we can observe what is the type of covalent bond here, students. Here the bonding is non-polar covalent bond. But in the case of those organic compounds where we have the more electronegative atoms in their structures, like here acetic acid or ethanol or acetone, beside carbon and hydrogen, oxygen is also present. So that's why these compounds are polar in nature. Polar, right? They are polar. All the three compounds are polar. So they are covalent in nature, either they are polar or either they are non-polar. I hope this is clear, students. Now we will see the next important character, that is a composition. Composition of organic compounds. Composition. In the case of organic compounds, we have noticed all the organic compounds, they are made up of carbon. It means carbon is a major element for all the organic compounds. Dear students, if we write structure of some organic compounds, for example, again we write the structure of, we have methane, CH4. Similarly, we have ethanol, C2, H5, OH. Ethanoic acid or acetic acid, CH3, COOH. Right, students? Similarly, we have acetone, CH3O, CH3. These are some organic compounds. Right, students? Now, if you see the composition of these organic compounds usually they contain carbon. What is their composition? In the organic compounds, carbon is present as major element. Okay? Carbon is the major element. Major element is carbon. Along with carbon, usually hydrogen is also present in majority of organic compounds. Hydrogen is also present along with carbon. Usually present along with carbon. Right, students? But the presence of hydrogen is not essential. हाइड्रोजन का पाया जाना लाजमी नहीं है. ठीक है? Usually it is present along with carbon, but presence of hydrogen is not essential. Presence of carbon is essential for a compound to be organic in nature. यानी कंपाउंड के ऑर्गेनिक होने के लिए क्या चीज़ ज़रूरी है कि उसमें कार्बन लाजमन मौजूद हो. कार्बन इज एन एसेंशियल एलिमेंट फॉर ऑल द ऑर्गेनिक कंपाउंड्स, और वी कैन से इट इज़ अ मेजर एलिमेंट और की एलिमेंट. यूजली हाइड्रोजन इज प्रेजेंट अलॉन्ग विद कार्बन, बट प्रेजेंस ऑफ हाइड्रोजन इज नॉट एसेंशियल. ठीक है? Now sometimes some other elements are also present in the organic compounds. For example, here you can notice these compounds contains, beside carbon and hydrogen, oxygen is also present. For example, in ethanol, in ethanoic acid, in acetone, oxygen is also present. Organic compounds may also contains halogen or nitrogen or sulfur, etc. I hope composition is clear to you, students. Now we will study the next important character of organic compound. Next is the melting and boiling points. Melting and boiling points. Dear students, we have discussed that all the organic compounds, they are covalent in nature. Since they are covalent in nature, right students, so we can categorize them in two categories. Either they are non-polar or either they are polar in nature, since they contain polar covalent bond. Now students, if they are non-polar in nature, then organic molecules, they are held with the help of weak intermolecular forces of attraction. यानी अगर ये नॉन पोलर होंगे तो इनके दरमियान जो इंटरमोलिकुलर फोर्सेस ऑफ अट्रैक्शन है वो बहुत ही वीक होंगी. That weak intermolecular forces of attraction are known as London dispersion forces. So due to weak intermolecular forces of attraction, usually they have low values of melting as well as boiling points. They have low values of melting as well as boiling points. Low melting points as well as boiling points, since they are non-polar and they are held together by weak intermolecular forces of attraction like London dispersion forces. Now if they are polar in nature, polar कब होंगे? When they contain atom other than carbon and hydrogen, for example nitrogen, oxygen, halogens, etc., then they are polar in nature. If they are polar in nature, then their melting and boiling points are higher, because then the intermolecular force of attraction among the organic compounds, it will be dipole-dipole forces. Dipole-dipole force of attraction is a stronger force of attraction as compared to London dispersion forces. So when they are polar in nature, they have high values of melting and boiling points. High melting points and boiling points. I hope this character is clear to you, students. Now we will see some more important characters. Next important character is the solubility of organic compounds. Solubility. Solubility. Students, if organic compounds are polar in nature, if they are polar, then usually they dissolve in polar organic solvents. Because we know very well what is the criteria of solubility. The criteria of solubility is like dissolves, like. It means if they are polar, then they will dissolve in polar organic solvents, and if they are non-polar, then they will dissolve in non-polar organic solvents. Now, if organic compounds are polar in nature, then they may dissolve in polar organic solvents. The polar organic solvents may be they are alcohols, right? Ethanol, like ethanol, acetone, ether, etc. These solvents are polar organic solvents. If organic compounds are non-polar, then they dissolve in non-polar organic solvents. Right, students? What are non-polar organic solvents? For example, benzene, carbon tetrachloride, and hexane. These solvents are non-polar in nature. So, if organic compounds are non-polar, then they will dissolve in non-polar organic solvents. Now, students, we will see other important characteristics of organic compounds. That is the rate of reactions. Rate of reaction. Rate of reactions. Organic compounds, usually they are covalent in nature, and hence their reactions are usually very slow, because they are covalent in nature. So that's why their rate of reactions are slow. That's why they need heating, thorough mixing, and catalyst to speed up the rate of reactions. It means special conditions are required to increase their rate of reaction. Right, students? What are the special conditions? That is heating, proper heating. Right, students? Then thorough mixing, catalyst, as well as condition of pressure. These are the special conditions which are required to increase their rate of reactions. Students, we know what is meant by rate of reaction. Rate of reaction is the change in the concentration of reactants or products per unit time. It means how many product is formed per unit time or how much reactant is consumed per unit time. That is known as rate of reaction. Now students, we will see some more characters. Next is flammability. Flammability Flammability, it means usually organic compounds, they are volatile. Volatile due to very weak intermolecular forces of attraction among their molecules. They are volatile as well as flammable. Volatile and flammable. They are volatile and flammable. Many of organic compounds, they are used as fuel. That's why they are used as fuels. For example, natural gas, coal, petroleum, oil. They are used as fuel like natural gas, coal, oil, that is petroleum, they are used as fuel. They all are flammable and they provide energy to us in the form of heat and light. They provide energy in the form of heat as well as light. I hope this is clear to you students. Now we will see other important general characters of organic compounds, that is the stability. Most of organic compounds, they are thermally unstable and decomposes on heating above 500 degrees centigrade. So we can say they are thermally unstable. They are thermally unstable. Right students? So that's why, since they are thermally unstable, so that's why they decomposes when they are heated above 500 degrees centigrade. I hope this is clear students. Now another important character of organic compounds, that is similarity in their behavior. Commonly it is known as homology. Homology. What is meant by homology students? It is similarities in the behavior of organic compound. Similarity in behavior. Similarity in behavior. There exists a close relationship between different organic compounds. This similarity in behavior has made the study of millions of organic compounds easier. They can be classified into few families based upon the similarity in their behavior. Now students, a series of organic compounds in which adjacent members, they are differ by a CH2 unit. Adjacent members, they are differ by a CH2 unit. CH2 unit, it is known as methylene. This unit is known as methylene unit. Right students? Adjacent members are differ to each other by a CH2 unit or a CH2 group. Such series is known as homologous series. Homologous series. And each member of the series is known as a homologue. Each member Each member of homologous series is called homologue. Now students, we will see some of the important examples of homologous series. For example, alkane series. Alkane series is a homologous series. Alkane like alkene, alkenes, alkynes, alcohols, and many more. Right students? We will discuss homologous series in the separate lecture. Right? Here you will kept one thing in your mind. We keep those organic compounds which have same functional group in the same family or the homologous series. Based upon the homologous series, we classify millions of organic compounds into few families. Right students? I hope general characteristics of organic compounds is clear to you students.